So this is continuing ecology. Pollution. Alright, so if this is a classic example of evolution, we have trees and we have dark colored moths and we have white moths, and the bark of these trees, they're called ash trees, were kind of white. Alright, so if you were a bird, okay, and you were looking for some tasty moths to eat, okay, the dark colored moths are going to stand out much more easily than the white colored moths, and so you're going to eat them more often. And so the population of moths is going to shift from being, maybe it was equally black and white, and it's going to become more and more white, okay, because the dark colored moths are getting eaten more often. But then, way back when, this thing called the Industrial Revolution happened. And because of that, the trunks of the trees got covered in ash and soot. Okay? And so then there would be dark colored moths, right? And there would also be that's a giant moth. Okay? Some light colored moths. So now, if you're a bird looking for some that's a mean looking bird. Looking for some moths, you see the white ones more often. So now the population is going to shift from being mostly white moths to mostly dark colored moths. Okay? And the reason is, this is natural selection. Once the trees became covered in soot, they know the dark colored moths suddenly had an advantage, a survival advantage. The white colored moths, or the light colored moths, did no longer had an advantage. Alright? So the trick here, the traits that allowed them to survive is camouflage. Okay? If you think back, once upon a day, you probably talked about cold-blooded and warm-blooded animals. A more sciencey way of saying this is that cold-blooded are exotherms. There's an R there. And warm-blooded are endotherms. Endo means in, therm means heat. So warm-blooded animals like dogs, cats, and humans make their own body heat. Okay? If we get cold, we might start shivering to warm ourselves up, but we can make our own heat unless it's extremely cold and we go into that thing where you're really cold, and I can't think of the name of the condition right now. Cold-blooded, so these are exotherms. So these are snakes, lizards, turtles. They have to go sit out in the sunlight and absorb the heat of the sunlight. Or maybe you have a heat pad for your pet snake, and that's where they get their heat from. Okay, so if you wanted to go catch lizards, a cold day or a cool day it'd be easier to catch lizards because they're going to have less energy to run away from you. Okay, so the exotherms tend to live in warm places. You're not going to find lizards living in the Arctic. Okay, there's not enough heat for them to absorb and survive. However, warm-blooded animals, because they make their own body heat, they can live in those Arctic places, like Arctic foxes, polar bears. Now, they have to consume food. If you think about snakes maybe only eat once a month, right? And that's all they need. because they don't have to generate body heat with that food. It can all be nutrition. Okay, warm-blooded animals, that energy, some of it has from the energy from food has to become body heat for them to survive. Okay.
Where's my cursor?
All right. So let's say we have some birds, and one has a beak kind of like this. That's a little more. Wait. A little bit like that. And one has a beak like this, and one has a beak kind of like this. Ignore that little glitch there. And some might have a beak kind of like that. Okay? And you know, birds like this are probably well, I kind of drew that. Well, they might eat nuts and seeds, like a parrot. These might eat insects because they're a woodpecker and they can peck into the wood, or that should be an I, shouldn't it? They can peck into the wood, they can peck into a hole to get the insects. This might eat meat, and this is not a good drawing. And again, this one might eat seeds, but probably not a nut. Like, it's not going to be able to crack open a pecan. This bird probably could with its strong jaw. All right. So there's a lot of ways that seeds can get dispersed in the ecosystem. Some seeds, like the maple, have wings, and as they fall, they rotate through the air and they travel. They don't fall straight down. They travel from point A to point B. Okay? Because if you're the mama tree, right, you want to keep surviving. If there's another oak tree growing right here, it could crowd you out and you're not going to get enough sunlight, or you won't get enough sun nutrients. So you want those seeds to go away from you and land somewhere else. Okay? Another way that seeds can disperse is some seeds have little spikes or hooks on them, so they get stuck in animals' fur, and then eventually they fall off or get picked off, but now they're in a new location where they can sprout. Another way, okay, is the seed is inside of a fruit, or maybe more specifically a berry, okay? And an animal comes along and they're like, ooh, this is some kind of little bird, and they eat the berry. And then eventually the bird, here's its little feet, here's a little wing, here's its tail, and then eventually it's going to poop out the seeds, okay? All it does is digest the flesh of the fruits, okay? It doesn't digest the berry. And so this is a way of the plant getting its fruit to another place, or its seeds to another place. Okay. Once again, remember there's autotrophs and heterotrophs. Troph means nutrient or food. You can think of it as food. Auto means self. Hetero means different. So an autotroph makes its own food. Okay, so they're photosynthetic or chemosynthetic. A heterotroph cannot make its own food. It has to eat something else. Okay. So autotrophs are either photosynthetic or chemosynthetic. bot keeps doing that. I'm sorry. And then heterotrophs are consumers. Okay. All right. Well, I'm going to stop there for today, and I'll see you next time.